Hi students, welcome to class with Professor Mead, your reluctant YouTube professor. Today we're going to be talking about validity and reliability. So when it comes to doing research, collecting data, going out into the field, making surveys, survey questions, doing observations, creating our DCI, one of the core issues that we need to contend with is how we actually measure what we want to measure. And a lot of that is connected to our conceptualization, right? So we spent all this time creating a definition for our variables that doesn't leave anything to doubt. And we've done this because we want to account for validity and reliability in the future of our research and to avoid bias. So I'm going to be using this visual throughout, right? So it kind of gives you a perspective of validity and reliability in terms of a visual aid, right? So if we measure what we intend on measuring, say for example, that's drug use, and we do it consistently over time, our measurement is both valid and reliable. Now, we can actually measure something reliably, right? So we can consistently measure emotions surrounding drug use, but we wanted to actually measure drug use, right? So we can be measuring something reliably, but not valid because we're not measuring what we intend on measuring. And so usually what happens is we're somewhere in between. We might have low to moderate validity and low to moderate reliability, or no reliability and low validity, those types of things. So let's talk about what validity and reliability is in terms of doing research. So when we're considering what method we want to use for collecting our data and what we're trying to collect, there are a few considerations that we need to take into account. We want to be focused on collecting accurate data, meaning we want to avoid our own bias or bias within our culture or society that would lead us to a result of biased data, what we might call junk in, junk out. So if you aren't paying attention to a bias, it could create a situation where you have low or inaccurate validity. Meaning you're not measuring what you're intending on measuring. Or you can have a problem with reliability because you chose a method that was easier to do for you personally than it was in terms of concern about having accuracy in collecting what you are intending on collecting. So if we focus on ease of collection versus accuracy, sometimes we're going to be using a methodology we wouldn't have chosen otherwise. So one of the ways that we can think about this is if we're talking about maybe, how productive you are at work. If I were to ask you on a scale of 1 to 10, how productive would you rate yourself at work? And say, for example, I am your boss or an agency that your boss hired to come in. You are very likely going to increase that number. So if you were to be honest with yourself, you might give yourself a 7. But because this is connected to your job in some way, you're likely to push that number up. Let's not go too high and get too cocky, right? So let's give ourselves a 9 on the work ethic, right? Because I'm being asked in a survey. Versus if we were to do something like unobtrusive observation in your workplace, we might find that compared to workmates, you might be an 8 or you might be a 4, right? In terms of how productive you are at work. And this difference comes about not because of necessarily people trying to lie, right? It's because we can have a different perception when we're observing somebody versus what they're going to tell us, right? We're going to have different data that comes through. So sometimes surveys or questionnaires, interviews, those are the most important or appropriate method for collecting the data. But sometimes they simply aren't going to get you the most accurate data. So you would choose another method like observation, whether it's obtrusive or unobtrusive. And so you're focused on getting valid data as a researcher, right? So when we say valid or validity, it's being precise and accurate, right? So it's hitting the nail on the head, knowing exactly what it is that you're trying to measure and doing it in a very accurate way. A good example of how challenging this can be is measuring poverty, right? So in the United States, we don't measure poverty based on people's actual incomes because, for example, if you live in California, an income of $40,000 a year in LA is much different than an income of $40,000 a year in Omaha, Nebraska, for example, right? And so you could really make your money go further. What if you have no kids versus 5 kids? What if you are a couple making $40,000 versus one person making $40,000? All of these things make using income as a way to measure poverty an inappropriate measurement, right? An inappropriate unit to be measuring. So what the US government does is they try to account for these variations, and they say, if you spend more than 25% of your income on food, you are technically in poverty. So if you have more children, you're obviously going to spend more time, more money on food. If you live in an area that's more expensive, your food is going to be more expensive. And therefore, it helps to balance out that validity, right? It's not the perfect way to measure it, but it's definitely a step up from measuring it simply by income. Now, the next problem becomes, can you continue to do that over time? So the first way in which we account for reliability is actually in our methods section. The most concrete, unambiguous definitions with your variables, the most detailed methods where you're outlining how you collected the data, what the definition of everything was, what the different units of analysis are, allows for somebody down the line, maybe somebody in the next semester, or somebody 5 years from now, or somebody today but on the other side of the country, could look at your method section and replicate your research. And if they can replicate your research and come up with similar data, they are accounting for the reliability of the data you collected for as well, right? Because they are reliably able to measure again the same thing it was that you were measuring. Now, even on our own, when we're doing our research, we have to account for reliability, right? So if I were to do unstructured interviews, and I want to talk to people about their perceptions of parenthood, right? Whether being a mom or a dad, what that means to them and how they feel about it. Now, I decide to do it completely unstructured. So I go in and I visit with 10 parents, right? And I do interviews with them. I have a general idea of what I want to talk to them about, but I have no pre-written questions. I have no pre-written answers, right? And I can probably follow a theme of parenthood, but I'm going to have questions and answers that are all over the place. I might be sort of measuring what I want to measure, but my reliability is shot. It just is all over the place. It's not going to be measuring exactly the same thing with every individual parent. So if I create very concrete, structured, unambiguous definitions, questions, sub-questions, and maybe even possible answers like a multiple choice or a Likert scale, I can then more easily be reliable or more easily assess the same thing over and over and over again. So structured, written data collection instruments like surveys often are very reliable. Now, that doesn't mean that they're valid, because you can reliably measure something that is not what you intend on measuring, quite often, or for a very long time. So talking about over a very long time, there have been some longitudinal research programs that have been going on, programs that have been going on, some of them since the 40s or 50s, and they have very reliable, concrete questions. So some of them on racism or sexuality have been asking people about these two topics, not just once or twice, but they have been doing it maybe every 10 years for this past 60 or 70 years, right? And so because the questions are written, they stay the same. So the research has been fairly reliable. Unfortunately, the way that we use language and the terms we use and what we would consider to be racism, or how we understand it today, or even sexuality, how we think about sexuality today, has changed over time. So although the research has continued to be reliable, it has become less accurate or precise or valid over time. So that's probably one of the most challenging things, especially with longitudinal research, is stability. Are the results stable over time, right? So you want to, as well, when you're doing research, one more time, right? Explain not just your questions and answers, but have a concrete, clear outline of how you're collecting your research so that you account for stability over time in terms of how someone else might be able to replicate your research. Okay, so what are some of the things that can impact your internal validity, right? Either make them, so remember, we want to be both reliable and valid, right? So what are some of the things that impact our internal validity, meaning we're going to measure what we intend on measuring? History. So history is the effect of any other variable. When you talk about control variables, you're talking about creating and accounting for other variables that may impact your variable. What do I mean by that? Say, for example, you want to do a test on whether people like coffee or tea more. So you decide that the best method for measuring this is that you're going to give away free coffee and free tea on campus for every day for a week. And so you do this every day from 10 a.m. till noon. And what you don't know is that there's another variable. And that is that somebody also has decided to give away coffee just around the block prior to where your stand is. And so everybody who already wanted coffee already got their coffee, right, for free. And so they pass your booth right on by, but the people who decide that actually like tea better didn't get the coffee and are pleasantly surprised, and they stop at your booth to get tea. From your perspective, people favor tea, right? And so what you're going to think is that if you don't account for that other variable, is that your results are going to show that people favor tea over coffee. When in fact you have a variable that was impacting your results, right? So you want to try to control for those things through your design, not only how you're collecting your data, but by knowing in advance what other things could potentially impact your variables, right? And you write those down under your matrix as control variables. You can also control for these things through random selection. So random selection, if you have, say, for example, an experimental group, and you're doing one control group and one test group. And so you decide to randomly put people into the controlled group or the test group. This means that all those other variables that could potentially be linking them, they both share the same class, they happen to be related, anything else, right? Both are getting physical therapy at the same location, all these other random things that could be impacting should be spread out through those groups. And so that random selection process and putting people into groups randomly hopefully randomizes those other variables that you don't know about. And so that's why, or how, we can control for history the effects of other variables through random selection. Another way to do this, especially if you have both together, is through size. The bigger the sample size, the less likely it is that those other variables are going to be connected enough to cause a problem. So they're going to be, by nature, more random because you simply have more people in your sample size. It can also be through the way that you collect your data sources. So let's go back to the coffee or the tea, right? So selection. Now, I decided to do my free giveaway as my data collection method, and I did it from 10 a.m. till noon. Well, it is possible that people prefer coffee before noon, but prefer tea after noon, right? So we may inherently, because of the way we chose to collect our data, be skewing it one direction or the other. Because I did all of my time frames in the morning, I skewed it towards what people prefer in the morning. Maturation means people change over time. So we talked about previously how you might have a cross-sectional study, right? And so you might have, people who are 10 years old, 20 years old, 30 years old, 40, 50, 60, 70, right? And so we can be asking the same question to all of these different groups, but because people change over time, they are likely to have varied or different responses based on their age. You can also see this, and it would be actually more accurate to see the change over time, is when you talk to the same person when they're 10, 20, 30, 40, 50, 60, 70, right? So now it's no longer cross-sectional. This is called a longitudinal design, right? So you are over time asking the same questions, and you will see the maturation or the changed answers over time. This also means that if you ask somebody regressive answers versus at the moment answers, you're gonna get different answers. So if I ask somebody how they felt about something that happened to them in the past, you're going to get a different response than what you would as if you were asking that person how they feel about that same thing as it's happening to them. The next one, number 4, is statistical regression. So people regress towards the mean or the average. What does that mean? Well, that means that when you get a large enough sample, most people would be part of that bell-shaped curve, right? We all tend to actually go more towards the center as we age or as time passes. So if we talk about politics, which is like a touchy subject, right? People tend to regress towards the mean. So what does that mean? That means that as you age, if you are on one end of this or other of the spectrum, that most people tend to regress towards more moderate political beliefs as time goes on. The next one, another way I like to talk about statistical regression. If you think about it in terms of intellect, as you age, your intellect increases. But as you age then as you get older, right, your intellect then slows down as well, right? So it increases and then speeds up. So we tend to, even if we had a very high intellect, it's going to over time kind of go more towards the average. Mortality. So people drop out of the study, and it's kind of this word where you're like, oh my gosh, people die. Yes, that could happen, unfortunately. But a lot of times this means, for example, if you're doing an interview or a survey, especially like a handwritten survey, people might get to a question, they're like, I'm done. Here you go. They don't finish it. They just don't finish. That means mortality. So if you're ever asked to do 20 interviews, you should do 25 because you're going to have at least a 10 to 20% mortality rate, no matter what you're doing. Interaction with the test and treatment. So we talked about before, like these different types of experimental designs. Now, a lot of time, those experimental designs, especially some of the more detailed ones, right, the Solomon 4-group design, is testing for the interaction between collecting the data and the treatment. In other words, what could be happening is that you could be sensitizing people during the test that will impact their treatment later on. So say you give somebody a test regarding their knowledge of a particular cartoon, and through that actual test, they actually learn a few things. And so then you have them take a test later on, you have them watch the cartoon and take a test later on, and you think that just watching the cartoon, which was the treatment, was what impacted their change in knowledge. But it wasn't just the cartoon, it was watching plus the pretest, right? So impacted the results through the treatment as well. So instrumentation, so using the same instrument, right? So if you are always using the same survey and you haven't changed it, your instrumentation stays the same. Your DCI, data collection instrument, stays the same over time, right? So that tends to help with internal validity. I gave you the example of the 2 research programs that have been ongoing since like the 40s or 50s. And because those instruments were concrete and it's been going on so long, that means that it has actually then started to fail in terms of internal validity because the culture changed, our language changed, our understanding of identities and our own culture has changed. Okay, and then the Hawthorne effect, and we talked about this one too. So the Hawthorne effect is people react simply to being studied, and we talked about this with the factory light study, right? So if they increase the light, the workers worked harder. If they decreased the light, the workers worked harder. If they increased the temperature, workers moved faster, worked harder. If they lowered the temperature, again, the same, it increased. They were not impacted by the changes in temperature or lighting. They were impacted by the Hawthorne effect. They knew they were being observed and studied, and therefore they reacted to it. Okay, this is a heavy lecture. External validity. So external validity simply means how generalizable is what you are researching, right? Can you generalize from your sample to the population? Now, say we're doing a case study. You cannot generalize from one person to the general population. Well, what if you're doing a case study of a business like Verizon? You can't generalize from the case study of Verizon. You know a lot more about the business Verizon or that particular nonprofit organization or that particular educational program, but you cannot generalize from that. Now, you don't always need to generalize to the population, so it's not always something that you're taking into consideration. Sometimes doing the evaluation of the nonprofit organization and having more data on that particular organization is the point of the research, right? So you may or may not have to worry too much about external validity. If you are, however, wanting to find out something like how does the general population feel about becoming vaccinated, then you do need to take into account something external validity, right? So you want to make sure that you are selecting as randomly as possible, and you're trying to represent the population as a whole. You want to make that random selection hopefully help you account for the history, right? So those external variables that you're trying to control for, and you're trying to make sure that you don't have additional reactive effect, meaning that people aren't reacting to some other variable other than the ones you're trying to measure. And if you combine those things, you have a more generalizable research. So that has a lot to do with sampling design, the methodology that you choose, and the size of your sample. And you'd be surprised, you don't need as big of a sample size as you think you would in order to understand the population as a whole. As a matter of fact, the larger the size you're trying to generalize to, generally you don't have to have a comparatively large sample size. If you're only trying to generalize to 50 or 100 people, you need almost all of those 50 or 100 people to be able to generalize to them. But if you're trying to generalize to 1 million people, you definitely don't need 80 or 90% of those million people in your sample. Generally, you can have something as low as 10%, 5% in your sample and still be able to generalize to that population. I'll show you later on in the semester how we do this. There's a calculator for it. I always love to tell everybody, back in my day, we had to walk uphill in snow both ways. There was no calculator. There was a table at the back of my statistics book, and that's how we figured it out. But our teacher would tell us how he walked uphill both ways in the snow, and they didn't have a table, and we were so lucky to have that table in the back of our stats book because they had to calculate it by hand. So, you know, c'est la vie, right? Okay, so let's kind of reflect here. Reliable and valid. You're measuring what you're intending on measuring, and you're doing it consistently, right? That's what we are attempting to do through design, through methodology, through a very well-written concrete conceptualization, and then through linking our questions directly into those conceptualizations of our variables. So a couple types of validity: criterion validity, content validity, and construct validity, right? So criterion validity, you are at the same time taking criteria and measuring it, right? So you're dividing up the criteria into little chunks, and then you're measuring it in those little chunks. And then you're trying to make a prediction with it, right? So you are trying to predict future events based on past events. So if you did an analysis, a criteria, if you're assessing the small criteria sections of, say, the stock market, and then you're using that to make a predictive assessment of what's going to happen in the future, that would be criterion validity. So it deals with whether the assessment scores obtained for the participants are related to the criterion outcome measures. I'm going to show you, we have you have an analysis in SPSS that shows you exactly what this means. So what you would be trying to do when you do this is for predictive SAT scores, do SAT scores predict post-secondary performance? So I'm looking at the criteria of SAT scores, and I'm trying to use it to predict future performance. Content validity deals with whether the assessment of the content and the composition is appropriate given what is being measured. In other words, does the test reflect the knowledge and the skills? That is internal validity. So am I actually measuring what I'm intending on measuring, right? And a good example of this would be, is there an appropriate representation of the questions from each topic area on the assessment that reflect the curriculum that is being taught, right? So is your exam appropriately measuring what you're actually being taught? So is it related to, or is it connected with? Construct validity deals with whether the assessment is measuring the correct construct. So is it measuring what you, like which construct do you want to measure? Do you want to measure someone's trait? Do you want to measure their attributes, skills, abilities, perception, right? You can have an intention of measuring somebody's opinion. What is the opinion on the legalization of marijuana? What is the opinion in Orange County on making alcohol illegal, right? So you can, are you measuring or assessing what you actually, the construct you want to measure? So the example given here is this human biology exam actually measuring human biology constructs that your teacher taught you? Okay. And this is how you would measure kind of what you want to. So Cronbach's alpha is a measurement done through SPSS. And so if you think of these circles, think of them as your variables that you created a conceptualization for, right? So you have all that huge definition in here, and you're going to take off little chunks of that definition, and every chunk you're going to write a survey question that correlates to just that chunk. So theoretically, all of those chunks together should measure this, right? And you can actually run a test on it in SPSS to see at what percent each one of those questions measures the chunk of the variable you're trying to measure. And if it gets too low, you can decide to take that question out, and then these will all shift as well. It may or may not help it, but that's how you measure it. Okay, so I hope this helped you understand reliability and validity. Have a great day.